Hi there and welcome to this video for Senior Physics on Quantum Mechanics. In this video we're going to explore the concept of cutoff voltage. Now this is going to extend from our knowledge of the photoelectric effect which we watched in the previous video. So what is cutoff voltage? Well, cutoff voltage is basically the process where we can determine the kinetic energy which is present in the electrons which are flowing across from the cathode to the anode. So if we look at the diagram which is down below, we can see that our photoelectric cell is present with our cathode and anode in our evacuated glass tube. We know that there is a microammeter which is going to measure the current, and we've also got a variable power supply. So when we put on our light at a just beyond the threshold frequency, we're going to generate a current which flows. The electrons are emitted from the cathode, they move across to the anode, and as a result they move back to that cathode, making our current. However, if we turn on our variable power supply and we pack the anode with electrons, eventually the force of repulsion will prevent the electrons from actually moving across from the cathode to the anode. So as we increase the variable power supply, what we'll notice is that the microammeter will decrease to eventually zero, which means that the electrons will not move. So remember that the voltage is joules per coulomb, so that tells us the amount of energy which is present. We know each charge of the electron is 1.6 times 10 to the negative 19 coulombs, so as a result we can work out the joules that is necessary to prevent that charge from moving across from the cathode to the anode. This point is called the cutoff voltage. So basically we can work out our kinetic energy using a formula. Now our formula here is the kinetic maximum, or the maximum kinetic energy equals the charge of the electron times the cutoff voltage. Now you'll see that if we look at Q is measured in coulombs, and we know that voltage is measured in volts, which is joules per coulomb. So basically what we get is coulombs times joules over coulombs. The two coulombs cancel out, and hence we're left with the units joules, which is the kinetic energy unit. So let's just recap. Basically what we're doing is we're allowing our electrons to flow from cathode to anode at a specific light frequency. That causes our current to flow. What we then do is we pack the anode then with electrons, which causes a repulsive force which prevents the electrons from moving across. The point where the current actually equals zero will be the point where we've got our maximum voltage. That will equate to the maximum kinetic energy that the electrons had. So how does this look on a graph? Well, if we look on the graph, we've got two lines which are shown, one for bright light and one for dim light. The key thing that you need to understand is that both curves are identical in that their shape shows that we've got a specific current, and then it drips off and goes to the cutoff voltage. So we know that if we've got a specific frequency which is above the threshold frequency, we will then generate a potential difference between the cathode and the anode. The result is the electrons will flow from the cathode to the anode, generating a current. This is if the voltage is in a specific direction. Remember, we're presetting at this case we're presetting it so that the cathode is losing electrons, the anode is accepting the electrons. There's our potential difference, and the result is the current flows. However, as we start increasing our voltage on our power supply, reversing the terminals, what we're generally doing is turning the anode into a cathode. What that does is it starts to drop the current which is flowing through the circuit. So at B you can see that the current is beginning to drop off. So the current keeps dropping off until eventually, as we increase the voltage of the battery, we're going to get to the point C where we're actually going to get no electrons which are going to move. This again is the cutoff voltage, and this equates directly to the kinetic energy which is found in the electrons. So what do we pick up overall? This means that basically bright intense light causes more electrons to be emitted. We can see this because we've got a higher current which is generated. So we've got more electrons which are emitted, which means we're going to get more current which is going to flow. More intensity does not, however, increase the energy of the photons. Remember, the photons are preset with their quantized amount of energy using energy equals Planck's constant times the frequency. Well, I hope you found that useful. This will be utilized in the worksheet which I posted on the iTunes U course on photoelectric cells. You will be using the graph and the cutoff voltage equation to determine what the kinetic energy is of the electrons. So do check out my website for other courses on physics and chemistry, and I thank you for joining me, and I look forward to you meeting me again. Bye for now.